Okay guys, so in the last video on sinusoidal functions, and again, remember, these functions, guys, they're just like sine waves, cosine waves. Just like you'd see on a monitor, a heart monitor or a radio wave, okay? That's why we analyze these, by the way, and we get good at it. All right, but anyways, the amplitude, guys, is simply the height. Remember in the last video we learned there's a middle line, a midline as we call it. And from that middle, the wave goes up a certain amount, reaches its maximum peak, and then it comes back down and it goes the same amount going down to reach its minimum peak, right? And so our goal this time is to find the amount is changing up and down, the amplitude. So here's our first problem. Notice they gave us the midline right here, right? And again, ignore the x. We know the midline's at negative 2.75. They gave us down here, ignore the x. Remember, we're looking at just height, vertical up and down measurements here, right? And notice this is again what we would call our minimum value. Okay, minimum value. Oh, my writing's getting terrible. It's always been terrible though, right? Minimum value. Okay, so, and that's the lowest that it goes. So basically, all we have to do is figure out what this distance is right here. Okay, that's the amplitude. The amount that it changes from the midline. Okay, so how are we going to do that? How about we simply take the minimum value and subtract it with the midline. Whenever you subtract, guys, matter of fact, we'll just write it underneath here. But whenever you subtract, guys, remember you're literally finding the distance between those two values. Now, to subtract it, since they're both negative, remember, if I subtract the negative, it becomes a positive, right? And so let's see here. 5 minus 5, of course, is 0. I have to borrow here, so 12 minus 7 is 5. And then, of course, 5 minus 2 is 3. So what did we figure out? Now, it is a negative value, but that's because we went down 3.5, you see? So what is our amplitude, guys? 3.5. Type that in the empty box down there. You will get credit for this problem. All right, let's try another one. Now this time, notice they gave us a maximum value again and a minimum value. Okay, so the logic here is, remember, the same amount up is the same as the midline's going to be here somewhere, right? The same amount's going down. So our strategy is, guys, how about we just find this total distance up and down and just cut it in half? That's your amplitude. Okay? So basically what we're going to do is average them, right? So this one's 2.5 up. Remember, ignore the x. This one's negative 4.5 down. So do you agree, if it's 2.5 up, 4.5 down, this total distance in red, if I add this together, is 7. And if it's 7 from here to there, the amplitude is half of that, right? Because it's going to go up and down a same amount. So divide by 2. In this case, our amplitude is 3.5. All right, let's do another one. This time, they gave us a maximum value, 3.8. Remember, ignore the x. We're only dealing with vertical or y values here. The midline is at negative 3.8. Well, guys, let's think about this one. We know from here to here is 3.8, correct? We know from here to there is 3.8 as well. A negative 3.8 if we use direction. But do you agree that this would be my whole amplitude from the midline? So guess what? I'm just going to add them together. And I get, carry the 1 there, the amplitude, guys, is 7.6. That's the height of the wave, right? The height of the wave is 7.6. Okay, let's try one more, and hopefully you already got the idea. Now, this one has just a bunch more waves. Don't let that scare you. Actually, because there's more waves here, guys, that means it's at a higher frequency. Again, we'll talk about periods and frequencies at a later time. But right now, all we care about is what is the height, the amplitude of the wave, right? So as you can see, I basically got close to the midline, but we know the height is at negative 3.7. We know the lowest is at negative, that's a negative there, 11. So guys, do you agree? All I need to do is find this distance and cut it in half. That's going to get me, if I go halfway, that gets me right to the midline, and that would tell me how high the wave is. So, let's take 11. Let's subtract 3.7 from it. Again, most of you will probably use your calculator for this. Let me go to black. It shows up a little bit better, right? So 11.0, we're going to minus 3.7. They're both negative, so we end up subtracting anyways. So let's see here. I'm going to borrow, right? So 10 minus 7 is 3. Line up the decimal. That's now 0. 10. So 7.3 is the height up and down of the wave. The actual height of the wave going up or going down is going to be half of that. So all we have to do is take 7.3 divided by 2. Let me go ahead and give myself some room here. So there's our decimal, right? So we know 2 times 3 is 6. Again, you probably want to just use your calculator. Bring down the 3. 6 times 2 is 12. 1 left over. Let's bring down a 0. 3.65. In other words, do you agree? From the midline here, it went up 3.65. It went down 3.65. Because 3.65 plus 3.65, if I add that together, is 7.3, which we did figure out right here, did we not originally? 7.3 would be the distance between the max and min. The midline will be in between them. The amplitude is from the midline up to one of its peaks, up or down. And that, guys, hopefully gets you to understand better not only how a wave is characterized, but now you know midline hopefully better, and you know max and min better, and of course you know how to find the amplitude better. See you around.